fence in a forest in England. And the picture on the right is from Flåmsdalen. And on the foreground of the picture, there's access for goats, and in the background there isn't, and the tree line's about 200 metres higher where there's no goats. And so that's grazing, but there's lots of other things that grazers do in ecosystems. And all animals. And this has a lot of effects. And one of those is that when grazers poop, there's often seeds in it. So this is the droppings of an elephant in African savanna, and there's a tree seed that has passed through the elephant and been deposited with a nice little packet of fertile material. Oh, God, what's the word? Yes, I could do it in Norwegian. Slightly closer to home, this is herdla in western Norway and poeranua growing out of a cow dung pat on the beach. And even we're guilty of this. This is a train line from Essex in England, which has rather old rolling stock of trains. And we've even found evidence of endozoochory in mammoths. I say we, this is Van Giel from 2008. They took 240 millilitres of mammoth coprolite and found seeds and fruits from around 25 taxa. So this is quite cool and quite exciting, and I get far too overexcited. Who poops the most seeds? It's like a competition. Okay, so you might think, biggest animal, most seeds. And true, there are about 300 seeds per poop in an elephant poo. But the winner is this dude, the tapir, because tapirs are frugivores, and so they eat figs, and figs have loads and loads and loads of seeds. So that little tapir could have over 3,000 seeds waiting right there, right now in that picture. Okay. But it's not just frugivores. Also, ungulates are depositing lots, and grazers are depositing lots of seeds. And grazers don't go out after seeds, but it so happens that the juicy foliage of the plant attracts the grazing herbivore, and all juicy leaves, I'll have those. And hidden among the juicy leaves are quite subtle little green or white seeds. Whether this is adaptive for the plant or not, I'm afraid is a story for another day. Okay, so focus on ungulates. I focus on ungulate grazers because they're the majority of large mammals, they're a major human food source, and they are passive consumers of seeds. So this is foliage is fruit hypothesis. And I managed to retrieve 64 different papers where someone had gone out, collected poop, stuck it in the greenhouse, and saw what came out. And so I stuck them all together. Okay, size sort of is everything. Bigger is better if you're looking for the number of seeds in the poop of a ungulate herbivore. These are log axes. So you've got things like cows on the far right-hand side. And I've labelled sheep because they're one of the smallest of the grazy type herbivores. Okay, and that's significant effect. There's slightly more to it than that because actually, as body size increases, the concentration of seeds in dung increases. So with large animals, you get more seeds per gram. But you get fewer species per 100 seeds. So if you want a diverse dispersal service, you might be better off going with a smaller ungulate. This is interesting from an ecosystem point of view because hunters take larger animals. And so it's going to affect your seed dispersal service where you've got a whole guild and people are hunting on the largest animals. Okay, there's a lot of mess in the data. What else might be going on? Body type doesn't have that much to do with it. Or rather, diet type doesn't, like grazer browser, doesn't have that much to it. Where they're grazing and browsing does. So you get very few seeds in dung when you're looking at deserts and tundras, but also at tropical savannas, which seemed odd. The other thing that's going on is the things that they're eating in the small scale. So the traits of species affects whether they get dispersed successfully in dung or not. Species from open habitats, species from nitrogen-rich habitats, but also species with round seeds, or with a small appendage that is more likely to get caught up in the mouth when something's grazing, that increases the chance that they get dispersed compared with their representation in the vegetation. So that's all the meta-analysis stuff. But this is a climate session. Okay, so ungulates mean that seeds can move around. It's clearly shorter to move up than move along. So are ungulates able to do us a service by helping our favourite species go uphill? Species are moving uphill. This is a review from different summit revisitation studies in Norway. And species tend to be moving significantly upwards over the last 100 years. So I've tested this, whether this is something to do with actual ungulates, in two different ways. The first one This is in Flåmsdalen in western Norway. I'm going to slow down because I'm talking way too fast. Okay, we know lots about what's going on in Flåmsdalen because there's this big project called Seaclim and it's been there forever. And there's 4 different things that can happen to you when your environment changes. You can tolerate it, you can adapt to it, you can move out, or you can die. So, this is work by Eric and Joachim about what happens to Veronica alpina when you move Veronica alpina downhill. So simulating it moving, it getting warmed by 2 degrees. They don't seem to be able to tolerate it. They don't germinate as well when you move them downhill. There's not really time for adaptation to go on because the 2-degree increase could be the next 40 years. And you can only get really 1 generation of Veronica alpina in a year. There's definitely some death going on. And so that we're not just talking about temperature, death is more when there's also more water. But can things move? And they haven't tested that. So I did. Okay. So I collated data on species maximum elevation in Flåmsdalen and compared it with Leeds flora's vegetation zones, where plants were expected according to Leeds flora, whether they were known to be endozoochously dispersed in terms of literature, and whether I could observe the smoking gun, them actually doing the moving in the dung in Flåmsdalen. So I got a gang of brave undergrads, and we went out to Flåmsdalen and had 2 study areas with various sites at various elevations and forest and meadows below the tree line, alpine herb communities, and some open woodland, just to see whether there was differences in habitat type and how the animals were moving. What we're focusing on today is the plant elevations. So we did fuzzy transects, walking from our highest elevation point downhill and recording the height at which we first encountered a new species. We did pellet removal plots to see what the actual biomass of dung going into the systems is in different habitats. And we germinated a load of dung that we collected while we were going along. So we had 22 different collection sites, ranging over nearly 1,000 metres elevation, over 6 visits July to October. Unfortunately, this was 2015, which was the worst year, and so there weren't actually many things seeding. So this can be considered a very conservative estimate of what's going on. This is what I mean by fuzzy transects. We kind of sort of went in these areas. We don't know exactly where we were, but we're trying to go a slightly different way each time. So fuzzy transect sounds way more professional than we just wandered about and had a look. Okay, there's lots and lots of seeds going into the vegetation from dung. It doesn't seem to have that much of an effect where in the elevational range you are. So the goats in Flåmsdalen, they're mad. They get milked once a day at 400 or 600 metres, depending on which of the 2 sites you're at. And then they go up above the tree line every night to go and graze. And then they come tramping back down again to get milk the next day. And so they're doing nearly 1,000 metres elevational shift every freaking day. So they're really efficient, whereas sheep are only going up and down. Oh, it's a bit cloudy. We'll go down a bit because it might get cold. So they don't go very far in relation to the goats. Okay. So starting on the big scale, did we find anything over its maximum elevation in Leeds? Yes, we did. Are they more likely to be endozoochously dispersed in terms of the literature? Yes, they are. Bingo. Are they more likely to be found in the poo samples we collected? No, they're not, because this was 2015, and so we only had 28 species, so that was a bit of a shame. The 4 species where we're really quite sure that we had a good difference between where we found them in the vegetation and where we found them in dung are raspberries, stinging nettles, bent grass, and wild strawberries. Wild strawberries having the biggest difference. This was 126 metres higher in the dung than in the vegetation. But Leeds Flora says that wild strawberries happen occasionally in the lower alpine. And seeing as we only found it around 800, then I'm not managing to convince anyone that wild strawberries are going to shoot uphill and it's all going to be fine. So the answer for test 1 about whether ungulates increase uphill movement is kinda, in a broad scale they are. But if you look down for the fine scale, then there's too much other crazy randomness going on to be able to really pin it down smoking gun style. The second test, I'm actually completely borrowing from Siri's master's thesis, which was whether grazing pressure or tourist pressure explains the variations in the changes in upper limit of alpine plants that we've observed over the last 100 years. So this is a resurvey study, a resample study, where people, including Kari and Arvid Odland, had gone back to summits that had been previously registered by botanists from 100 and 150 years ago, resurveying them with the same methodology and going, okay, we've got a whole load of summits, mountaintops. We know how high they are. Are things on higher mountaintops than they used to be? And the two things that we tested there were grazing and tourists. So with grazing, you expect the actual grazing effect to reduce plant movement, trampling to reduce plant movement, but seed dispersal to increase it, and also nutrients getting higher up the mountain. With tourists, there have been really big increases in tourists in Norway. Tourists trample plants, so that might mean that plants have less chance to go uphill. They gather plants, but they also have seed dispersal. We've all seen the state of our boots at the end of the day in the middle of summer. And so Siri went out and she basically asked pretty much anyone you could possibly assume might have an opinion about this, about how it went. She even asked the army, which is hardcore. I'm scared of the army. Okay. So all in all, the resample data set that we're using is 1,065 observations. That's species times locations. 51.5% of those observations were higher. So either in a higher plot where we had plot-based data, or on a higher summit where we had summits as plots. And then we did some models about which things had an influence on whether things go higher up. And the thing is that increased grazing pressure or high grazing pressure, or it being really easy for the sheep to get to the mountains, meant that, in fact, things moved up less. So the more sheep you have, the less stuff moves up. It moves up a smaller amount, it's less likely to move up. Whichever we test, grazing means that plants are moving up less. So test 2 and test 1 are in conflict. That's not important. So the upper elevation limit has moved for plants, but grazing dampens the effect. So, is poop going to help save plants from climate change? Yes. Ungulates have the capacity to move loads of seeds, deposit them all over the place. They go miles. No. If they did, we'd be seeing perfect rain shifts. We wouldn't have to stress. There'd be no species that are going downhill. And what it all comes down to in the end is what happens to the seed after it's been pooped and when it hits the ground. And I'm going to leave the last word to the sheep. Thank you. No, I'll just talk loud. I hate it.
Then you talk to that.
Yeah, no, I'll talk loud. Everyone can hear.
Okay. Thank you, Amy. We have plenty of time for talks because it looks like Francesca hasn't showed up. So raise your hands. Questions?
The question about the fuzzy transects in Flåm and the highest elevation for single species, can you repeat that 6 times, you said?
As in how often we walk downhill? Yeah.
I could imagine there's a lot of variation for each species, so I was just wondering about the range in elevation for that.
Every time we went to the highest elevation on that transect, because that's where we had some pellet clearance plots. We'd have liked to have got higher, but we were a bunch of slightly unfit, slightly incompetent nerds. And so we didn't really dare to go above 1,100 because it got cold. Also, when we started, it was snow to 1,000, so maybe I didn't go to 1,100 on the first round because it was still snow. 2015 sucked. But yes, every time we went up and down at least once. And we also did registrations if we found something on the way up that was over where we'd found it. So there was a lot of very stochastic species at location going on. We also used the data from seed clim control plots. So there we have much more control over what's going on, but it's a very small area. So we didn't get a lot of the shrubs in that data set, for example. But I would say about 1/10 of the data, the highest location was actually from the seed clim data set. So we've got really surprisingly good coverage for nerds and a shitty summer.
More questions?
What do you think happens when the seeds hit the ground?
I think it really varies. So I didn't have time for this, but we also looked at dung beetle activity. And if a dung just lands on the ground and then it gets dry, and it's a big bit of dung, chances are actually the seeds aren't going to germinate out of that because it forms a crust. Getting into gross details here, but it forms a crust. And so actually it's really hard. There's a big picture of a big bit of sheep dung somewhere. If you're 5 centimetres down in a big dung pat and you fall on a dry day, that pat can get hard and then you're never going to germinate. Unless you have good seed bank longevity. But if you get broken open because there's loads of dung beetles that day, great. The dung beetles only hang out in the meadows, so you want to land in the meadows. So it depends where you land. A, how much you get dried out, B, how many dung beetles you've got access to. But then there's the tunnelling dung beetles, and they take big lumps of dung, take it 30 centimetres below the ground, bang, end of story for the seed. So there is so much going on after something gets deposited on the ground. There's lots of things.
Do we have time if someone wants to ask more questions?
Because I talk way too fast.
No, then we should applaud our speakers.